There we are. And Saad is going to continue the discussion on branching in code repositories. But I think maybe there's probably a lot to refresh about branching in general because it's a pretty important topic.
Yeah, thanks for the introduction, Sean. Let me share my screen. And, sorry, hold on. Am I sharing the right? Did you see the Enclave home screen?
Yes.
Okay, great. So I think it was about 3 or 4 weeks ago where we talked about branching, both code branching and datasets branches. And we showed some examples of using these concepts in code workbook. And so maybe I'll start with a little refresher on the data branches and how we use them for releases of the EHR data that we get from sites. And today I wanted to show more examples of using that within code repositories. More people use the code workbook tool in the Enclave, but there are some people who use code repositories. There are some pros and cons, and I can cover that at the end of this presentation. But the main way I think of them is that code workbook is good for analysis and maybe quicker iteration and displaying visualizations, while code repository is a more robust tool when it comes to code versioning and many people collaborating on the same project to write data pipelines. And so the first thing I'm going to start with is, so this table is, I'm not going to show the preview because this is the identified datasets, but this procedure occurrence table is one of the OMAP datasets that you will find in the data catalog, whether you have level 2 or level 3 access. This one has the procedures for each patient. It's a gigantic table. This one is 518 million rows. And so I'm just showing the details tab because I don't want to show the preview. Usually for this training, we only show synthetic data, and I'll show that in other cases. But what I wanted to show here is usually if you have access to this table and you open it, the data set itself, it has multiple branches. And the way it's structured here is that the latest data will always be in the master branch. So we have releases roughly every week in N3C where sites send additional data to us. And so we refresh the data sets with more EHR data. And so you will always find the latest in the master branch, which is the branch that opens by default when you open the data set. However, at every release, we also save the same data for that release in what we call release branches. So if you do a search here and you start typing release version, I think we're up to the 50s right now. So release 50 was October 21st, and then a week later, release 51. So roughly every week we get more data sets and we save them in these branches. And why is this useful? For many reasons, but you may want to base your analysis on a specific date and say, maybe you want to run your analysis as of last October and for the data as it was last October, and you don't want it to be refreshed every time there is a new release. If that is the case, then it's good to use as an input of your analysis, not just the latest cut of procedure occurrence, but you can choose to use release 54, for example, and say, I'm going to use this data set as it was on October something. And so it's also useful because sometimes you run an analysis and then you want to freeze your results, meaning that you want to freeze the results as of a certain date, meaning or more like freeze the input. So you start your analysis, you have your inputs as of release X, Y, Z, and then you start writing code and developing analysis, but you don't want you want all your changes to run on the data as it was on that specific date of the release. And if you don't do that, then every time you run your transformation, it will run on the latest input data. So your results might change over time, and you may not want that in some cases, especially if you're at a certain point where you're done with your analysis and you want to export it outside of the enclave. So you go through the download review process. So that's generally how it works in terms of using the branches for data to capture the data for each release. This is the tool Foundry, which is the platform that the enclave, the N3C uses, has this additional concept. Usually, most of you are probably familiar with branching in the concepts of branching code and versioning code. But in the enclave, we also have data versioning. So each data set can have multiple versions of data or can have multiple branches, and each branch has a different cut of data. So that's kind of an introduction. Now I'm going to go to this synthetic data person table, so the table for demographics. And I'm going to play with it a little bit in a code repository and show you how to, on one hand, use a different input branch than the default master branch, and on the other hand, also create your own branches and start to play with it. So in this folder, the Enclave users group, all of you should have access to this one. And there's a link from the training portal, but let me create a code repository. And by the way, this is meant to be interactive, so feel free to stop me if you have any questions. I'm happy to stop and divert and answer them. So let me give this a name. So let's call it branching examples repository. And these are just helpers to provide you templates. In code repository, you have multiple options. You can write Python, SQL, or Java. And so let's start with some Python code repository here. I hope the screen resolution is enough, but let me know if it's too small. So on the left-hand side here, you have all your the scripts. So you can create scripts here and start writing code that transforms data. When you create a Python transforms code repository, it gives you some examples and templates that you can start off of, but you can delete these Python scripts and run and create and run your own scripts. This is more to help you if you don't know the basic skeleton of how a Python transformation should look like. So I'm going to, let me rename this examples.py, and I'll just call it my first script.py. And let's remove the comments here. And so usually the way it works for a Python transform, and I'll show another example for SQL, if you prefer writing SQL queries, is usually you have this weird syntax here, which we call a decorator. Usually it's at transform. And inside this decorator, you specify your input and output data sets. So if you have one input, and the way you specify them is you have these functions called input and output. And so I want my input to be this person table. And usually the way you specify the input is by either providing the path of the data set. So meaning where the data set is saved in the enclave, and the path, usually the location is here. And you can follow the folder tree to find the location. Or you can also actually provide what we call the resource ID, which is kind of a unique identifier of the data set. Is this thing I just highlighted. Usually it starts with RI, which stands for, which is a shortcut for resource ID. So that's another way to identify a data set. But for our case, let's just grab the location. And we're going to go back here, and I'm going to pass the path here. So right now I'm telling my transform to take this data set called the person table, save it in this source variable. And this is my only input. I can have actually multiple other inputs. So I can have something like, if I have multiple data sets, I would maybe call this source 2 and give the path name of the other table. Similarly, you can also have multiple outputs. It's a slightly different syntax. And I won't show that right now. I can show that later. But know that this code repository allows you to start with multiple data sets as inputs and output one or multiple data sets as an output. And so usually you have a compute function here, which takes your source, basically your input data set here. In this case, it's a Python data frame. And you can write your code here and play with it. So this is what we're going to do. This is just provided as an example. I'm using this identity function from this utils script, which is saved in my projects.dataset, basically here. This function is just the identity function. Again, this is just as a skeleton to show you that you can also define functions and utility scripts in other places in this repository tree and call them from this script. So I'm just going to remove that. I am just going to do a basic transformation where I select, I want to grab maybe 2 columns from this person table. So I'm going to grab person ID and maybe gender concept ID. Let's grab the first 2 columns. And this is my compute function. So I'm going to return this data frame, which is the result of my transformations here. It's a very basic and dummy transformation. My goal here is just to show how branching works. So I'm going to delete this. And I don't need this PySpark library for now. Let's merge in changes. And we're going to run it quickly. I don't know if my internet is being a little slow today. Let's see. I want to refresh. Okay, so so this is the code I wrote. Before I build it, so what build does, it basically runs the code and saves the output in this. Actually, you know what? Let me change this path and give it a more meaningful path or somewhere I can find. So I am going to grab this location and pass it here. So this is my output path, and I remove the repository name. And so this is going to be saved in this folder, and the name of the data set, let's just call it for now output dataset example1. And now I am going to commit my changes. So commit just means saving this version of the code. I can give a commit message or a comment. Let's commit that. And before running the full build to save the results in this data set, I can run a preview. So it's a faster way to check this, sanity check your code. It just runs your code on a sample of the input. So it's usually faster. And it can surface some, if you have syntax errors or other errors, more quickly than waiting for the build to run and then fixing it and rebuilding again. So here, as you can see, it sounds like my code is working fine. I'm selecting these two columns, and these are the outputs. It only does it for 10,000 rows. And now I can run a build, which will probably take a couple minutes. And so while it's running, let me talk about the concept of the fallback branch and how we can play with it. Usually when you run code in code repository, and you say, I want to use these input data sets. These input data sets usually has a master branch and can have other branches, which corresponds to different versions of the data. So usually, so which branch am I going to take as an input? The default is usually whatever branch you have here. So if it's the master branch, I am going to take the master branch version of this person table and run my code against it. If I have a different branch, so let's say I'm going to create for now a dummy branch.
Hey, Saad.
Yes.
Would you be able to zoom in your browser window a little bit? This class
sure,
description is not quite as good as my contacts.
Is this helpful? Or I think I'm doing some sort of a screen sharing with, does this one help or it's still small for you?
That's certainly better.
Okay, okay. Yeah, sorry about that. So while this is running, let me create a dummy branch. So the way you create it is you're on the master branch right now, which is the default, and you can create a new branch. And so right now, theoretically, if I want to run this code, first, it's going to try to look for for the person table, it's going to try to look for this branch and then use the data that exists in this dummy branch. However, if you look at this person table, it doesn't have a dummy branch. And so that's where the concept of fallback branch comes into play. When your input data set doesn't have this specific branch, it will fall back to the fallback branch, which is the master branch, meaning that even though I'm in the dummy branch of my code workbook, I'm going to use the data of the person table that is in the master branch. Let's go back to here and see if my script finished or if it's still running.
How's that indicated? Is there a warning or something that you're falling back?
There are, so usually the default is always the master branch, but you can change that in the setting in branches. So in branches, you have this option called fallback branch. So it's saying if an input data set to your transform has not been built on the current branch, an attempt will be made to locate a build version from a list of alternate fallback branches. And usually that fallback branch is master, but you can change that. And you can say, hey, if this input data set doesn't have any data on my dummy branch, I want you to check the other branch called something else, not master.
And is that in the logs, whether you got your preference or if you got the fallback?
Yes, yes.
Okay.
That's a good question. Let me show that actually right now. There are multiple ways to look at it. You have it in the history tab of each data set. You have what we call the transactions or the builds. So every time a data set runs, you have the details of the job. And you can look here at the job specs. And so the job specifications are telling you, okay, these are the input specifications. So for this particular data set, the branch I used is master. So I use this data set resource ID here as an input to my current transform. It's actually easier to look at. So this is the history of all builds, but you can look at it from the details tab of a data set. So if you look at the job specifications, this is the latest job that ran and updated this data set. And so you can look at specifications such as this was the user ID who last ran this and refreshed this data set. And for the inputs, this data set was, if it's null, that means it's master. If it's not master, it's going to explicitly say, oh, we use this branch of this data set. And in fact, I was going to run an example here to show you that in this code.
Thank you.
So does that answer your question? Okay.
Yes, it does. Thank you.
So let's open this. So this is the result of my transform that is in this repository. You can see that the input is person table. And if you go to details and go to the job specifications, you can see the branch of my input, which is the master branch when it's null. Now, let's say I want to actually, this person table has multiple branches, and I want to use the data for this newer version branch, or maybe older version branch. Not the data that is on the master branch. So the way you specify that is, like I said here, the default is always the master branch, but in this input function, you have options. So you can say, in fact, if you hit the comma, you'll see all the options. So alias is the path of the data set, and you can specify the name of the branch that you want to use in your transformation. So here I'm going to use older version. So I'm going to do branch equal older version. And that's it. Basically, now I'm saying run the same transformation, output this data set in the master branch, but my input that I'm going to be using the data that exists in this branch called older version. And if I run that in a couple of minutes, you'll see that the job specifications changed and that your input was taken from this older version branch. Does that make sense? Any questions about this?
So you can specify which branch to use in the left upper corner, right, where it says master, or you can also specify it in the code in the transform decorator?
Correct. Well, this is more like, usually you use this for branches that you create yourself to manage, let's say, multiple people working on the same code repository, and someone has branch A working on this specific aspect and someone has branch B. And I'll show an example of that, but yeah, usually this basically determines in which branch the output of your transformation is going to be saved. But you also have control over the input, meaning that even if you're on a specific branch, you can say for inputs, no, actually, I want to use the input of this other branch. And usually this is most helpful when you're dealing with release versions of OMOP datasets. And so while this is running, let me actually create a separate branch called branch A and start making some changes.
Saad?
Yes.
Could one achieve the same purpose using RIDs? Each branch has its own RID, or do I misunderstand that?
No, that's a good question. The RID is a unique identifier for the data set, but a data set can have multiple branches. So the RID does not like uniquely identify a branch. And in fact, this is a little small. I'm not sure why. I'm not sure if you can see, but it says this is the dataset resource ID / master. Master is the branch you're looking at. But if you change the branch name, you'll see that it's the same resource ID. And I'm sorry again for the small font. And here it's / older version.
So I guess my question then is, if you want to specify back to source df equals input blah blah blah, an alternative to the syntax you're showing us here would be the RID followed by / and the branch name.
No, it will be always. It will be always. The function has the same signature, so this first argument could be a path or a resource ID, but then you have to do comma branch equal. In fact, it gives you an option if you hover over it to automatically change this to a resource ID, as you can see here. So now you have it as a resource ID and then branch equals the branch name.
Okay, so either way, you still have to specify the branch as a separate parameter.
Correct, yes, correct. And so now we're in branch A. Let me make a couple of changes and then run that, show you the output, and maybe try to merge it with the master branch. And so maybe one change that I would like to make is add another column, gender concept name. And maybe let's leave another change for, let's let's leave another change for later. Let me just do this like minor change. And now I'm going to commit my changes. And let's run this build. And so now this code is running, is taking the data of person table from this branch and then write into this output, but it's going to write on branch A, not on the master branch. So let's give it a second. And in fact, I can actually, let's go back here. This is probably done running, yeah, a few seconds ago. So now the input is always the same person table, but if you look at the details, I think the easiest way is usually to check the job specifications. You can see here that the input I'm using that has resource ID, this one, which corresponds to the person table, I'm using the branch older version. So I'm not using the master branch of this data set. But it's still, the output is still saved in the master branch because that's where I ran my code. This is the code I ran in the master branch here. Does that make sense? Let me switch back to branch A, which is still running, and I'll show you how the results look like. Usually it takes, let me check, just a minute. Yeah, less than 2 minutes. So hopefully it should be done soon. While this is running, so branching in code repositories helps you collaborate on the same project, maybe multiple people collaborating. And so let's say I'm working on preparing this data set, and then another person in my project is using this data set and joining it with another. Basically, we're splitting our tasks, and we're keeping the master branch as the version of the code that is the most up to date, and that's the one that where the work is finished. So if I'm user A, if I'm collaborator A, and I did this work on my own development branch, when I'm done, I can merge my changes to the master branch. So I can propose my changes, and this will essentially create a pull request, and I can give it a title, something like added one extra column, maybe a description. The column is concept, gender, concept name. And so here you can see what I'm trying to do is merge my changes, my code from branch A into the master branch. And it's showing me here the diffs. So I changed this path to basically a resource ID, and I also added this column. So these are my two changes. This is just like some sort of hidden file for configuration, so don't worry about it. So I can create a pull request. The pull request is a change request to merge my changes into the master branch. So this is telling me what files were changed. This is just an overview that says all the checks were run and there's no like code error, so I can merge if I want. But I'm not going to do that now. I'm going to something that I kind of forgot to do, and I think is a good practice, is once you start creating branches and collaborating on the same code repositories, it's always good to lock the master branch so that it doesn't get ahead of your changes. So let's say I'm user A, I'm collaborator A, I did that changes, but at the same time, someone else came to the master branch and just did maybe another change. Let's call it, let's say I'm in master branch and I want to add month of birth. And let's commit that. Now, if I go back to my pull request, it will tell me that I have a conflict. And let me quickly actually jump on my run. It should probably be done already, just to show you the results. So yeah, it was done a minute ago. So this is branch A, in which I added this extra column, gender concept name. And so now my output dataset has multiple branches, right? There is the master branch. And if I open the code repository here, I will see the logic corresponding to what's in the master branch. And this is what it generated. So it opens the code as it is in master branch. But there's also a version which is in branch A. And here, if you open the code repository, it's going to open it on the branch A, I believe, which is a different version of the code. And so there are a few, there's this, I don't know if you've played with this before, but there's this comparison tab, which is quite useful because it lets you do comparisons between either two different data sets or the same data sets but different branches. So for example, here I'm comparing branch A with the master branch. And it's like some high-level comparisons. So you can see differences in the code logic. You can see differences in the columns. So this one has one extra column called gender concept name. And sometimes you can see data differences. So this one, and what's useful about this, well, you have some high-level statistics here about the size of the data sets, but it's also useful because you can not only compare branches, but compare different versions of runs. So in master branch, I did one build at 126 and another one at 134. So maybe I want to compare my branch A as of this last run to my master branch as of 126. So this is a different data, and you can see here that there's some high-level statistics that changed in this column. This version has an additional column, gender concept name. Let's see, I can show include that, yeah. And person ID has also some different statistics. So it's useful to kind of like double check and do some version control. Sorry, do some diffs between different versions of your code and data. You can actually also do the same thing in Contour. And I showed that 4 weeks ago, but I'll just mention it briefly. But if you open a data set in Contour, you can also here say, I want to analyze this data set, and I want to analyze the data as a master branch. But I also want to compare it with the same data set for branch A. So I can, for example, open a new tab, a new path, and maybe let's copy the location. Let me choose branch A. So now branch A has 3 columns, and maybe I can do some sort of join with the other path. And let's add maybe a prefix. Let's call this branch A. And yeah, so what this allows me to do, I can join on person ID. What this allows me to do is to do some more custom comparisons. This comparison tab here gives you some high-level differences. But if I want to do some more aggregated or custom metrics and I want to compare two versions of the same runs, I can do it in Contour. And I can do that in Code Workbook or in other tools. So going back to the code repository, yeah, I was talking about the pull request. So let's go back to my pull request. What I said is I've created a pull request to merge in branch A into master, but at the same time, someone else in my team edited the master branch without creating a separate branch. And so we have some sort of conflicting changes. Now, if I go back to my pull request and I open it, now it's giving me a warning. And it's saying the branch is out of date and there are some conflicts. So sometimes the conflicts are easily automatically resolved. So if I click on resolve conflicts, the first thing I want to do is I want to pull in the latest code from master branch into my branch before I'm able to merge back my changes in the master branch. So it's also called rebasing my branch. And so now it's saying that I have some conflicts. So basically, these are my changes. And this is the conflicting change. So that other person in the master branch edited the same line, but has a different edit. So here I can say accept current change or incoming change. Let's say I want the incoming change, and I want to add to that gender concept name. And so now my conflict is resolved in branch A. I can commit. This will take a couple of minutes to rerun the checks, and I can merge my, oh, interesting. And I can theoretically merge my current changes in master. But the reason I showed this, and in the process of fixing it, I'll let me first let's run the build here. And while it's running, the reason I mentioned this is that it's always good practice if you're collaborating on the same code repositories to kind of like lock the master branch and only allow edits in different development branches so that people don't step on each other's toes, and there's a process to create pull requests to merge into masters. And the way to do that is in the settings tab. If you go to the branches configuration, you can say that you want to protect the master branch, and this gives you some options. So basically protecting it means no one can edit the master branch. Whenever you want to change the code, you have to create your own branch and do your changes and then create a pull request to merge to master. And usually for the pull request to be successful, it requires some basic checks to run. But you can also require an approval for maybe a specific person, or you can leave it with no approval. Let me edit this and let's remove the approval step. So now that I did that, if you go to the master branch, you can see this icon here that says it's locked. And if I try to make any change here, I can't. it says this is read only. So you'll have to create your own branch or edit your existing branch and then merge it into master. So let me go back to my branch A and look at my code and see if it's running. And then once it runs, I just want to check that it's working properly. I can merge my pull requests. Are there any questions so far? So I guess just to recap here, there were two things that I wanted to convey in this presentation. One is data sets can have multiple branches. So when you create a branch in code repository, the output data set will have a new version that is saved in that branch. And so here, my output data set has multiple branches. And the second thing I wanted to convey is for your inputs, usually the default is to take the input from either this branch or the fallback branch, which is usually the master branch, but you can force the input to be taken from a different branch in here. And this is very, very useful when you're using domain tables, OMAP domain tables that are in the data catalog. If you want to pin your results and pin your code to a specific release that is not the latest, the latest release.
So can you show how to do this in code workbooks also?
Yeah, of course. Let me open, let's do that from the person table here. I'm going to show it in code workbook. So let's say analyzing code workbook. There is, I think, a recording, the presentation of 3 to 4 weeks ago has a recording where I was showing exactly the same process in code workbook. So you can have more details, but I'll show it now on a high level. So let's say code workbook branching example. And let me save it in let's save it here. So now I have this person table in here, and say I create a transform, maybe in SQL, just a select star from person, and run this. It will basically run based on the default branch. So if you look at the branch section here, oh, you know what? I opened it from older version. So it's pinned to older version. Let me click on reset. Usually when you open a data set from the master branch, let me stop this and rerun. You can look at the branch tab. When nothing is specified, that means it's using the default master branch. But you can say, hey, I want to use this input person table. This is just synthetic data, so you won't see the release data sets. But if you have level 2 or level 3, you should be able to do to say, I want to use the data as of release V50, for example. Or in this case, I want to use the input, but for the branch older version. And then I can run this code here, and now it's going to take the data from this branch older version. Does that answer your question, Cornelia?
It definitely does. Yeah, that's what I was looking for.
Okay, great. You also can create your own branches in Code Workbook, as I mentioned a while ago, but it's less sophisticated than the options you have in Code Repository. Now that this ran, let me actually check my pull requests. Not sure why it's showing it as still being edited, but let's check. What is the warning? Yeah, that's just, I haven't built the data set, but it shouldn't be a big deal. So now I can merge my changes through the master branch, so which is basically adding this extra column. And I can do squash and merge. Or you can specify that in configuration, but you can have some other person review and approve before you're able to merge it. Now that it's merged, I can choose to either keep my branch A or delete it. Sorry, that's not what I accidentally clicked on that. But you can choose to delete your own branch if you're done with it or keep it. But if you go back to the code and now go to the master branch, you can see that now it's up to date. Now, if you want, that doesn't mean that you'll still need to rerun the build for this master branch to have it to have the data set refreshed. But the code now is what it is here. So I guess since we have 5 minutes left, one quick thing I wanted to show, and then I'll open up to questions, is just some documentation that could be useful, because I know some of you maybe are wondering which tool is better to use between Code Workbook and Code Repository and what are the differences. There is a nice documentation page that shows the main differences. And I'll show you where to get that from. So on the training material in the homepage, if you go to the documentation, and I'll send you that as a link, but I just want to show you how to get to that. And let's go to documentation of Code Repositories. There is a section here, I believe, called Comparison Code Repositories versus Code Workbook. This will help you figure out which tool is best suited for what you need. And this is a comparison summary here. The main things that for me are obviously different is that if you're an R user, you can only use Code Workbook. You can't use it in Code Repository. And visualization you can do in Code Workbook, but not in Code Repository. But then there's a lot more sophisticated things in Code Repositories. You can use a debugger. You can write unit tests. You can write what we call incremental transformations to optimize your code. Maybe I can talk to that at some point in another presentation. But this gives you the high level differences of the two tools. So let me send you that. And with that, I'm going to pause and see if you have any questions. Does the branching concepts, data sets versus code, is it making more sense?
If I may jump in with a question, I was just wondering if you could explain the difference between merge and squash and merge.
So that's a good question. When you, it mostly has to do with the change logs of your commits. So what I mean by that is in Code Repository, you have, if you look at each script, sorry, 1 second, you have a history of all the file changes. So each one of these corresponds to a specific commit, and a commit meaning you do some change and then you commit your changes and you're saving that version of the code. So you have a history of all the changes. When you create a pull request So let's say you're on a specific branch and you do multiple commits and each one has their own change and comment. When you create a pull request and then you approve that pull request, the master branch of your script here will have the additional changes that you made to your branch, the additional commits that you made to your branch A. When you do squash and merge, you're basically squashing all the commits of in branch A into one single commit of your pull request, saying, okay, here is my one change that I made, and this is what I want to see here in the history. So this is my, and I think that's what I'm doing here. In my pull request, I'm only seeing one change instead of like multiple small incremental changes corresponding to my commits. Does that make sense?
Yeah, so it sounds like for most purposes, squash and merge has the advantage of not cluttering up the history with a lot of little details that aren't really important.
Absolutely. You know, you make a lot of incremental small changes and maybe you do some corrections, and ultimately a pull request is supposed to be a clean change. That's what you want to keep. So you don't want to keep all the history of your small commits, and some of them might be insignificant. Yeah, but that's exactly that.
Do you lose all the commit messages, or are they consolidated into one long message?
I think they're consolidated. Well, so the changes are consolidated. So when you look at the diffs, they're all consolidated. But I think for the commit messages, if you have multiple ones, they're probably, let me look at branch A actually. Let me look at master. This is, I think they're probably consolidated. Even the commit messages, they are replaced with the main message that you write on your pull request. But if I'm not mistaken, it gives you the option to keep them and put them in one message or rewrite your own commit message.
Okay, thank you.
No problem. Any other questions?
Thank you so much for this, Sal.
Yeah, no problem. Yeah, if you have follow-up questions, you can Slack me or reach out to us. And if there are any, if there are any topics that are not in the EUG's training module and that you'd like to be addressed, you know, feel free to reach out to us and we can prepare them for you. But yeah, up to you, Sean.
Thank you, Sada. That was awesome. I just wanted to note that we don't yet have a topic for 2 weeks from now. I have a couple of leads, but if anyone has any suggestions or would like to volunteer something, now's a good time. I'm going to see if I can try and get the some folks to demonstrate the new concept set editor version 2, which is being rolled out. Thumbs up from Ken. Awesome. Okay. Have a good one, y'all. I'll stop the recording.